All right, guys, remember when you're joining, you need to have your Katie ISD number in your name.
Oh,
Katie ISD number in your name. All right, just give me a quick second and we'll get started soon. I hope. All right, guys, give me like 2 minutes and we'll get started. All right, let's go ahead and get started. All right, so like always, I'm gonna be doing homework problems and he's gonna kind of I am doing an extended practice problem. So I'm gonna start with the homework on number 7. So on this one, on number 7, what we need to do is we need to combine these two rational expressions, and list out our restrictions. So anytime we have any type of these type of problems, the first thing you always want to do is factor everything out. When everything's factored out, the easier the problem is going to be. So the top, that's going to factor out to W plus 6 and W minus 4. That's negative 24, and you get positive 2W for the middle. And the bottom is going to factor out to W plus 6 and W minus 5. All this plus 8 over W minus 5. That second one didn't need to be factored out, so we're good to go. Now I need to figure out my LCD. So if I look at my factors in the bottom, I have a W plus 6. I don't have any other W plus 6s anywhere else. So I have a W plus 6 in my LCD. And I also have an W minus 5, and I have that both in both those rational expressions. So I only put it down once in my LCD. And that's what my LCD is going to be. So I need to make sure that both LCDs have, or both denominators have the total LCD. This first one right here, it already has the whole LCD in the bottom. And because I want to combine them, I don't need to mess with it. I can leave it alone. But the second one right here, I needed to have a W plus 6 on the bottom. So I'm going to multiply top and bottom with that W plus 6. And when I do, this first one isn't going to change. It still stays W plus 6 times W minus 4 all over W plus 6 and W minus 5. That second one, I can distribute the 8 to get a W plus 48 all over W minus 5 times W plus 6, which will give me W squared plus W. Actually, I don't need to distribute that out. I'm not sure I'm doing that. Keep it in factored form. W minus 5, W plus 6. Combine these. Krishna, go ahead.
Wouldn't it be a lot easier if you just cancel the W plus 6 in the starting fraction?
It would have
then
been,
you can just add W minus 4 plus 8 over W minus 5.
It would have been, I didn't see that. Sorry, I'm kind of a mess right now. I was rushing to get this thing started. Yeah, that would have been a lot easier. But let's finish it off this way. Or actually, we'll do it the correct way because we have a test coming up. So let's go ahead and back this all up. Sorry about that. Eight over W minus 5. So like Krishna said, I'm not sure why I didn't see that. That all should be the second step. Cancel these out. And I'm left with W minus 4 over W minus 5 plus 8 over W minus 5. Add like terms together. They have the same denominator. We have W plus 4 on the top over W minus 5. That's going to be your answer. And for my restrictions, my W cannot equal -6 because of the W plus 6 on the bottom, and the 5 because of these W minus 5s. That's going to be your answer. Thank you for that. And that's how you solve it out. Any questions about that? Are we okay? All right, let's keep going. Now on to number 15. So now it's a whole number minus a rational expression, but that's not really going to change how you solve it because any integer or any number is still going to be a rational expression or some kind of fraction, so I can still combine them. So first things first, we're going to factor everything out. So the 7, I can just leave it alone. But this second rational expression right here, on the top, I can factor out a 3 and be left with a 2x squared minus 3x minus 14. Right, 12, yeah, 14. All over x squared plus 2x, I can factor out an x and be left with x plus 2. And then I still want to factor out this 2x squared minus 3x minus 14. So I need factors of -28 that add up to -3. And that's going to end up being factors 7 and 4. -7, +4. So we get x minus 7, x plus 4, divide the numbers by the leading coefficient, and we get that this is going to factor out to 2x minus 7 and x plus 2. So that's what the top's going to factor out into. So when I factor it out, I get 7 minus 3 times 2x minus 7 times x plus 2 all over x times x plus 2. That's everything factored out. And now before I start canceling stuff out, I'm going to figure out what are my restrictions. So my restrictions, they're going to come from the denominator. So in this case, my restrictions are just going to be this and this right here. So x cannot equal 0 or negative 2. And then I can start canceling stuff out. These x plus 2s cancel out this time. I'm not going to miss it. And we have 7 minus 3 times 2x minus 7 all over x. And my LCD with this 7 and this x is going to be x, right? I don't have anything in the denominator for the 7. It's just a 1. So my LCD is just x. So I'm going to multiply the 7 with x over x to end up getting 7x over x minus 3. Well, we can distribute that 3n actually. It'd be a little easier. Distribute this 3n to get 6x minus 21 over x. And when you combine like terms, I have 7x minus 6x. That gives me negative x plus 21 all over x. And that's going to be your answer. Any questions about that? Makes sense. Kanish, go ahead.
Yeah, how would it be negative x? Wouldn't it be positive x?
No, 7x minus, yeah, wow. My mind's not with me today. Yeah, you're right. Positive x. Thank you. Positive x. Faith, go ahead.
I have a question about number 18 and just like how to set it up.
So we, when test review days, what we do is I go over my own problems. At the end, I'll take individual questions.
Okay.
All right. Any questions about number 15 before we move on? All right, let's keep going. So on this problem here, I have a division into a multiplication. So what I'm going to do is solve out this part first, and then I'll multiply that result with the 3t squared plus 4t minus 4 over that denominator. But before I even get into that, what I want to do first is I want to factor everything out. When everything's factored out, everything becomes a lot easier to solve out. So for the 2t squared plus t minus 6, we'll do that in purple. I want factors of negative 12 that add up to 1. That's going to be 4 and negative 3. So I have t plus 4 and t minus 3. Divide that by its leading coefficient. And we get that 2t squared plus t minus 6 is going to factor out to t plus 2 times 2t minus 3. All of that over 4 times t minus 3. And now I want to factor out this 3t squared plus 7t minus 6. So from there, I want factors of my a times my c, so negative 18. Factors of negative 18 that add up to 7. That's going to be 9 and negative 2. So I have t plus 9, t minus 2. Divide that by my a values of 3. T used to be a 2, not a 9. T minus 2. So what I end up getting is that we're going to divide by the top ends up being t plus 3 and 3t minus 2. And on the bottom, I can factor out a 6 first, and I get t squared minus 2t minus 3. And now I'm going to factor out, but I'm going to finish up the t squared minus 2t minus 3 in the next step. But before I do that, I'm going to factor out these right here. So the 3t squared plus 4t minus 4, that one, I want factors of negative 12 that add up to 4. That's going to be 6 and -2. So we have t plus 6, t minus 2. Divide these by my 3. And we get that we're going to multiply the top by t plus 2 and 3t minus 2. And the bottom, we'll do that in a different color. We'll do that in red right here. And that one, I want factors of -18 that add up to 3. That's going to be -6 or +6, sorry. +6 and -3. So I have t plus 6, t minus 3. Divide that by your a value, which is 2. And we get that the bottom part is going to end up being t plus 3 times 2t minus 3. And that's how you factor all that out. It's kind of bunched up on the side. But that's your total factored out part right here. Also for the test, you guys are going to need to be good at factoring. There's going to be a lot of factoring on the test. So if you're not good at it, you're going to need to practice because we told you from the beginning of the semester, it's a lot of factoring this semester. Any questions so far? Are we good? All right, so let's go ahead and solve this out. Tanish, go ahead.
So the factoring, like, it's always just going to be the X method and grouping, right? There's not going to be any other types of factoring.
For tomorrow's, I mean, not tomorrow's, Thursday's test, yeah. We're not giving you factoring by synthetic division or anything like that, no.
Okay. All right, thank you.
All right. So let's go ahead and solve it out. I'm going to do this part first. But before I do that, I need to factor out this green part right here. So that's going to factor out, we're just going to rewrite it. It's going to end up being 6 times t minus 3 t plus 1. Right, -3, yeah. That's what's going to factor out into. So before I do anything, I'm going to figure out my restrictions. So my restrictions for this problem are going to be that t cannot equal 3 because it's t minus 3. It cannot equal 3 again because it's other t minus 3. It cannot be -1 because that's t plus 1. This is a division problem right here. So I'm going to end up flipping this fraction. So I also cannot equal -3 because that's t plus 1. And also cannot equal 3t minus 2 gives me a positive 2/3. I cannot equal 2/3. And then when I go to this other multiplication, I only need to worry about the bottom. So t cannot be -3 from this. I already have that. And a positive 3/2. So that's what t cannot equal. All right. So these are all my restrictions. And now I'm going to go ahead and start canceling stuff out and see what I can do. So for these first two, the purple and the green one, I can cancel out. Well, before we cancel out, let's actually just flip it so we can see what's happening. So I'm going to flip the second one first to get t plus 2 and 2t minus 3 all over 4 times t minus 3 multiplied by, I'm going to flip this to get 6 t minus 3 t plus 1 all over t plus 3 and 3t minus 2. All right, now I'm going to start canceling stuff out, and I'll deal with this part right here in a bit. The t minus 3's cancel out, and the 6 and the 4 can reduce down to 3 and 2. So what I get when I reduce all this down is I have t plus 2 times 2t minus 3 all over 2. And I still have this 3 right here. I'm going to put this 3 in the front right here. And I have this factor of t plus 1. And these two factors of t plus 3 and 3t minus 2. And then from there, I'm going to multiply this with this blue and red part I factored out right here. So I'm going to multiply it with t plus 2, 3t minus 2, all over t plus 3 and 2t minus 3. Isabella, go ahead.
If you wanted to, could you just cancel them all when they're set up, like the 3 of them?
Yeah, you really could. I just don't like to do it, like show it that way, because it can be a little confusing. Like you could cancel out like this top with this top and this bottom, that would work. And then you can also cancel out, this in yellow, this bottom with this top. You could do it that way, that's fine. I just think it can get a little confusing, so I just kind of go step by step.
Okay, thank you.
All right, and then from here, keep canceling stuff out. These 3t minus 2s cancel out. The 2t minus 3s cancel out. Unless I'm missing anything, that's it. So what I'm left with is this 3. I have 2t plus 2s, so t plus 2 squared all over 2 times t plus 3 squared, with the restrictions that we listed above. Tanish, go ahead.
Can you scroll down a bit? I just wanna look at something. Yeah, aren't you also supposed to have a t plus 1 on top?
Yes, I don't know what's wrong with me. I keep missing little things like this. Thank you.
Oh no, it's alright. I also do this all the time.
Yeah, but I'm a teacher. I shouldn't be having these little brain farts so often right now. But yeah, thank you. T plus 1. There we go. Because we have this right there. We didn't cancel out. Don't do that on the test, please. All right. Any other questions or any other mistakes I might have made? Are you ready to keep going? Cool. Let's keep going. Put this in by accident. Don't need it. All right. Now we're on number 38. So for this problem, there's 2 ways to go about it. I'm going to go about it the way that I like to do it, and that's going to be multiplying everything by the LCD. All right. So before I multiply everything by the LCD, I have this really weird 1 minus x here, right? I don't want anything as 1 minus x when everything else is in the form x minus or plus some number. So I'm going to take this negative 3 over 1 minus x, and I'm going to fix it. So first thing I can do is factor out a negative in the bottom to get negative 3 all over negative of negative 1 plus x. This negative in the bottom can go on the top to give me a positive 3 all over x minus 1. So I can replace negative 3 over 1 minus x with a positive 3 over x minus 1. Just kind of an aside to see what we did. So I can rewrite this whole thing as 1 over x minus 1 minus 2 over x plus 2. All of this over 1, is it 1? Yeah, 1 over x plus 2 plus 3 over x minus 1. So that's kind of the first thing I would always do. I would fix the problem to have all my denominators kind of in the same form, x minus or plus some number. And then from here, my LCD, if I look at all these denominators, all these like little mini denominators that I have, I can see that I have x minus 1 in both those places. So I have to have an LCD of x. I have to have x minus 1 in my LCD, and then also I have an x plus 2 in both of those places. So I have to have an x plus 2 in my denominator as well. I don't want to repeat anything, so that's what I have. Also, I just saw the chat. Sorry, someone's asking, will the slide and video of the Zoom meeting be posted on Canvas? Yes, it will be. That's why I'm doing it a day early, so I can have time to put it all on YouTube and Canvas. All right. So that's my LCD. And what I'm going to do is multiply, this whole thing by the LCD. So it's actually, let's move this up here. That's my LCD. So what I'm going to do is I'm going to multiply this whole thing, the whole actual fraction, by my LCD of x plus 2, x minus 1, all over x plus 2, x minus 1. And so it's kind of being multiplied like this. So what I get When I multiply x plus 2, x minus 1, when I distribute this into the first rational expression, the x minus 1's cancel out, and I'm left with just an x plus 2. When I distribute the same thing into negative 2 over x plus 2, the x plus 2's cancel out, and I'm left with a 2 times x minus 1. And then when I go on the bottom, I can distribute the x plus 1, x minus 1 into the first fraction there. The x plus 2's cancel out on the top, and I'm left with a x minus 1. And then when I distribute it into the second fraction, the x minus 1's cancel out, and I'm left with a 3x plus 2. Everyone with me? Do we know how we got to that part? All right, let's keep going. Now we're just going to solve it out. So I have x plus 2 on the top. Distribute the negative 2 to get negative 2x plus 2 all over x minus 1 plus 3x plus 6. Combine like terms on the top. I have a negative x plus 4 all over 4x plus 5. I really have nothing else I can do there. That's going to be my answer. But something that we need to make sure we do is that I need to check what are my restricted values. All right, so when I go back to this part right here, to the very beginning, and when I fix it right here, I can see I have factors of x minus 1 and x plus 2 only, and that gives me restricted values. That tells me that x cannot equal 1 or negative 2. I know that for sure. X cannot equal 1 or negative 2. But at the same time, I need to see, well, I have this big fraction right here in the bottom. I need to know, when is that equal 0? Well, this 1 over x plus 2 plus 3 over x minus 1, this is the same thing as saying this 4x plus 5. So I need to know, well, 4x plus 5, when does that equal 0? Because it cannot equal 0. So if 4x cannot equal negative 5, or x cannot equal negative 5 over 4. And that is all my restrictions. Tanish, go ahead.
I just had like a question like overall. So instead of multiplying like all 4 of the fractions by common denominators, only the ones that you're adding and subtracting need to have like common denominator, right? Because the other ones get multiplied, so it doesn't matter, right?
Wait, I'm sorry. I mean, like, I only need to have a common denominator at the top and the common denominator at the bottom. Is that what you're saying?
Yeah, that's what I'm saying.
You're right. That's a different way to solve it. So there's the way I like to do it. I'm sure. I think your teacher's Mr. Stevens, and the way he likes to do it too, I'm sure, is just cancel out the denominators everywhere. So what we do, we multiply everything by the LCD of everything. So that gets rid of all the denominators right away while keeping the same value. Well, the other way to do this problem is like what you're saying, where I can just combine the tops, combine the bottoms, and solve it out that way. So I find the LCD of just the top part, just this part right here.
Yeah.
Find the LCD of that part only, and combine those, and then divide that by what you get when you combine these two together. And that's a different way to solve it. It works. Either way you like it, it works.
Okay. Does it end up canceling the denominator or something in the future step?
Yeah, because I'll just redo this problem and do it that way. So I can show you the other way to do it too.
Okay. Thank you.
Problem. Garish, go ahead.
Yeah, Mr. Aziz, just want to confirm that the sign change on the denominators due to us changing the 1 minus x to x minus 1, right?
I'm sorry. Yeah. I did the sign change because I changed from 1 minus x to x minus 1 per exactly.
Okay, thank you.
Good, great. All right, so let's go ahead and do this problem again. But we're going to do it the other way to do it. All right, so the other way to do it is like what Tanish was saying. What I can do is I can just only focus on subtracting or adding the tops and the bottoms. Well, first I'm going to fix the bottom part. We already saw how to do it. I'm just going to get 1 over x minus 1 minus 2 over x plus 2. All of that over 1 over x plus 2 plus 3 over x minus 1. All right, so once I fix that sign is what we get. So the other way to do it is to kind of focus on only the top and then only the bottom, kind of look at them as separate things. So when I look at only the top, well, for them to be able to combine these two fractions on the top, I need to multiply this 1 over x minus 1 by an x plus 2 on top and bottom. And when I do that, I get x plus 2 all over x minus 1, x plus 2. And I'm going to subtract from that what I get when I fix this second 2 over x plus 2 to have the same denominator of x minus 1 times x plus 2. And I get that by multiplying top and bottom with x minus 1. And now they have the same denominator. And that is going to be all over what I get when I fix the bottom as well. So 1 over x plus 2, well, I need to have an x plus 2 and an x minus 1 on the bottom. So multiply the 1 over x plus 2 with an x minus 1 on top and bottom over x plus 2, x minus 1. All of that plus what I get when I fix this 3 over x minus 1. So this needs an x plus 2 on top and bottom. So 3 x plus 2 over x minus 1, x plus 2. And now I'm just going to kind of combine like terms. So the top, they have the same denominator, so I can combine them to get x plus 2, distribute the whole negative 2 to get negative 2x plus 2. All of that's going to be over, or before I do that, actually. All of that over the denominator of x minus 1, x plus 2. Now all of that over what we get when we fix the bottom. So same denominator, so I'm fine with that. And the top I have x minus 1. And I can distribute this 3 to get a positive 3x plus 6 all over that denominator of x minus 1, x plus 2. Right, I can do it this way. And then what I end up getting is that this whole green equation, when I combine like terms, I get negative x, the x and negative 2 give me x, negative x plus 4, all over x minus 1, x plus 2. That's being divided by that whole thing in blue. So I have x and 3x gives me 4x, negative 1 and 6 gives me positive 5, all over x minus 1, x plus 2. So now this comes a division of rational expressions. So from here, I'm going to go ahead and figure out my excluded values before I start canceling stuff out. So I see that x cannot equal 1 or negative 2. That's the same thing here. And this 4x plus 5 tells me I cannot equal negative 5 over 4. That's the same exact excluded values we got in the previous problem. So that's okay. After that, I'm going to go ahead and cancel these out. So I can flip this blue one. So when I do, I get negative x plus 4 over that LCD of x minus 1, x plus 2. And now it's going to be a multiplication problem of what I get when I flip these of x minus 1, x plus 2, all over 4x plus 5. And now because it's a multiplication problem, I can just kind of cancel across, and these just cancel out. And I end up with the same exact answer that I had before. They're both perfectly good ways to do it. Go with whichever way you like more. It doesn't matter. We don't care, or we shouldn't care. Whatever way works best for you. Is that what you're talking about, Tanish, solving it out this way? I'm going to assume it is. Any questions about this problem? Are we okay? All right, let's keep on going. Now we're on some of the newer stuff that we've done before. So now we're on solving rational expressions. So, Tanish, go ahead.
Can you just go back 1 second? I thought I noticed something. It's probably just a silly mistake. Okay. Yeah. This is my fault. I know this, but I just can't catch it. For the denominator, I keep getting 4x minus 7 and not 4x plus 5.
I'm gonna have to see your work to see what you did.
Okay.
4x minus 7 in the denominator right here.
Yeah, in the final answer, like, Because like you
So
distribute the
you're bringing x minus 1 here or x plus 1?
um over there
My mouse is
y- yeah
check there. It should say x minus 1 plus 3x plus 6. I'm sure that's where you probably messed up at.
okay, all right.
Do you see it or no?
No, because my work is sort of a mixture of both of the other two methods you did. It's kind of like it's complicated, but I'll look at it again.
You're gonna mix and match between the two methods is gonna get very, very confusing. Just pick one and stick with it.
Okay, got it.
It's gonna be better for you, I think.
All right, thank you.
No problem. Any other questions? Ready to keep going? Let's keep going. All right. So now we're going to be doing some solving rational expressions. So just like before, the first thing you should always do is factor everything out. So this part on the top, I want factors of negative 24 that add up to negative 4. That's 6 and 4, 8 and 3. Hold on, mine's not working. Does that have factors? I don't think it does. 1, 2, 3, and 8 doesn't work. 4 and 6 doesn't work. Yeah, so it's prime. So that's prime. That's fine. Well, I think it's prime. If I'm wrong about that, let me know. And then the other one, this bottom part right here, factors of negative 24 that add up to 10. That one's easier, 12 and negative 2. So for the blue one, I can write that as x plus 12, x minus 2, divide them by my a value of 3. And I know that when I rewrite the second part right here, I should get x plus 4. And 3x minus 2. And we're going to rewrite that now a little nicer. So what I get is 3 over x plus 4 minus 2 over 3x minus 2 equals the top of 3x squared minus 4x minus 8 all over that factored form of x plus 4, 3x minus 2. All right, the top didn't factor out, and that's perfectly okay. So now I need to figure out what my LCD is going to be. So my LCD, or I guess we need to do our restricted values first. I can see my restricted values is that x cannot equal negative 4 or positive 2/3. That's the exact same thing we had here. And my LCD, I guess we'll do this over here. My LCD, I have an x plus 4 here, a 3x minus 2 here. That's the exact same thing we have on the other side of the equation. That's my LCD. So I'm going to multiply this whole thing by my LCD. So when I multiply 3 over x plus 4 by my LCD, what I get is 3 times x plus 4 and 3x minus 2 all over x plus 4 minus 2 times my LCD of x plus 4, 3x minus 2 over 3x minus 2. That's going to equal 3x squared minus 4x minus 8 over x plus 4, 3x minus 2 multiplied by the LCD of x plus 4 and 3x minus 2. Everyone with me so far? Are we okay? Tanish, go ahead.
I just have a question. So why didn't you multiply like each fraction by the thing that you needed to make the denominator the LCD? Like why didn't you multiply the 3 over x plus 4 times 3x minus 2 like on the top and bottom?
Because I'm multiplying I have an equal sign here, right?
Yeah.
So what I did is I multiplied both sides by the LCD. So it's like if you have an equation, it's like multiplying both sides of the equation by 2. So
Okay, but I'm thinking about it as like a fraction, like multiplying the top and the bottom of the fraction by the same number, so it'll still be the same thing, right?
it would be. That's a different way to go about it. It's just not the way I would go about it. I mean, you could do it that way. Like you could combine the 3 over x plus 4 minus the 2 over 3x minus 2. You could combine this together to one fraction and have like one rational expression equaling another rational expression, and you can solve it out that way. That would work, and it's fine to do it that way. But this is the way that I preferred. I prefer getting rid of the denominators. So I found the LCD of everything and multiplied both sides of the equal sign by this LCD, because when you do, the whole denominators end up canceling out.
Okay, got it. Thank you.
That's how I do it. You could do it that way. To me, it would work. I think with problems that are similar to this, it'll be harder than it needs to be, but you totally could do it. I don't know if Mr. Stevens would take points off. I would ask him first. I doubt it, but I don't want to talk for someone else. Me personally, I wouldn't care.
Okay, that's just the way I saw it. So
yeah, but the way kind of we taught you and how we do it is like this, but it still works your way. All right. Anyway, I'm gonna start kind of combining these. So I have 3 times 3x minus 2. That's gonna end up giving me a 9x minus 6. Then I have a negative 2 and an x plus 4, which gives me negative 2x minus 8. And that's all going to equal 3x squared minus 4x minus 8. And now I'm going to start adding like terms. I have a 9x and negative 2x. That's 7x, negative 6 and negative 8. That's negative 14. That equals 3x squared minus 4x minus 8. We can start adding like terms. So kind of move everything over to the other side. 0 will equal 3x squared minus 11x. Add the 14 over to give you a positive 6. So now you can solve this out any way you want to. Quadratic formula, complete the square, factor it, I don't care. Just solve it out somehow. I'm going to factor it. I want factors of 18 that add up to negative 11. That's negative 9 and negative 2. So x minus 9, x minus 2, divide the numbers by 3. And what we get is that 0 equals x minus 3 times 3x minus 2. So we get that x equals 3 or 2/3. I'm going to double check my excluded values from the very beginning. I see that x cannot equal 2/3 because there's an excluded value. So my only answer is x equals 3. Any questions about that? All right, let's keep going. All right, now let's do some more problems. So, number 51, a boat travels at 60 miles per hour in still water. So this right here is the speed of the boat without anything pushing or like pushing against it or pushing with it. The boat travels upstream 15 miles and back downstream 15 miles in a total of 2 hours. So that tells me that the time upstream plus the time downstream, that's supposed to be a down. Let's go ahead and fix it. That equals 2 hours because it goes upstream and downstream in a total of 2 hours. And I want to figure out what the speed of the river's current is going to be. So to figure that out, I'm going to kind of set up the equations for both of these. I'm going to figure out, well, what is the equation for the time upstream and what is the equation for the time downstream. So time is equal to distance divided by speed. So the time upstream, I'm told we go 15 miles up and downstream. So I know for the time upstream, the distance is 15. And we're going to divide that by its speed. So I'm told the speed is 16 miles per hour in still water, but that's without anything pushing against it. When you're going upstream, you're kind of fighting the current. So if you're going 16 miles per hour, you're going to have a current pushing you back some c amount, right? If the current's, let's say 2 miles per hour, you're going 16 minus 2 or 14 miles per hour. So in this case, my speed is 16 minus whatever the current is, because that's pushing me back. And I'm gonna add to it my time downstream. My time downstream will be the total distance, which is still 15, right? I'm still told it goes up and downstream at 15 miles. And its speed is going to be its speed when there is no current, which is 16. But when you're going downstream, you have like kind of a current pushing you along and kind of helping you go a little faster. So this is going to be 16 plus c, and that all equals 2. And that's what I want to solve. My LCD is 16 minus c, 16 plus c. I'm going to multiply all these out with that LCD. So you multiply your LCD with 15 over 16 minus c. The 16 minus c cancels, and I have 15 times 16 plus c. When I multiply the blue part with the LCD, the 16 plus c's cancel out, and I'm left with the numerator of 15 times 16 minus c. And that equals 2 times my LCD of 16 minus c, 16 plus c. And we're just going to solve this out. 15 times 16, I have no clue what that is, figure out. 15 times 16, that is 240. So I have 240 plus 15c plus another 240 minus 15c. That's going to equal 2 multiplied by 16 minus c times 16 plus c. That's the factored form of a perfect square trinomial. So we get 16 squared, which is 256 minus c squared. I can add like terms on the right. These cancel out, and I have 480 equals 2 times 256 minus c squared. And I can divide both sides by 2, and I get 240 equals 256 minus c squared. I'm going to move the c squared over to the left side and subtract 240 to the right to get that c squared equals 16, or c equals plus or minus 4. It doesn't make sense for a current to be negative 4 miles per hour, so we just say c equals 4. And that is your answer. Any questions about that? Make sense? All right, let's keep going. All right, number 55. Jim and Albert have to paint. They have to paint 6,000 square feet of a hallway in an office building. Albert works twice as fast as Jim, and working together, they can complete the job in 15 hours. We're going to write a rational equation to model the situation, and how long would it take each of them working alone. So remember, the time, to figure out the time they can do something together, you're going to add up the time it takes them to do it individually, more or less, right? So in this case, Albert works twice as fast as Jim. So if Jim goes x speed, goes like 1 over x, Albert is going to go 1 over 2x. And I know that when they work together, they can complete one singular job. That's where the 1 on the top comes from. They're completing one job in 15 hours. So this 1 over x is telling me Jim can complete one job in x time. This 1 at the top right here, this 1 over 2x, tells me Albert can finish one job in 2x, or twice as fast as Jim. And they both can finish that same one job in 15 hours. So that's how I can figure out what my x is going to be, because I want to figure out how long it would take them to do it each individually. So I'm going to figure out my LCD, and that's 30x. I'm going to multiply each of these by 30x. 30x divided by x is just going to give me 30. 30x divided by 2x is 15. And 30x divided by 15 is 2x. Alden, go ahead.
I just want to ask, I know it's 1 over x plus 1 over 2x, but wouldn't it be that Albert would be 1 over x, not 1 over 2x? Because wouldn't that be double the amount of time if it's 1 over 2x, not half the time?
No, because it's remember this is you can kind of think of it the same thing as the distance, speed, and time formula. It's time. It's sorry, no, it's gonna be like the one's kind of like I don't want to say distance, but it's kind of like your distance, the amount of work you're doing divided by your speed. The speed is x. The speed is 2x.
Yeah,
like,
so you have 2x, and aren't you multiplying x? So you're multiplying the amount of time it takes.
I don't understand what you mean. If Albert works twice as fast as Jim, right?
Yeah.
So if Albert finishes in x time, Jim finishes it in 2x.
Yeah, that's what I was saying. I thought earlier you said that Albert was 2x, which is why I was confused.
Did I say that?
I thought I remembered that. If I remembered wrong, I guess it's me.
I don't know. Maybe I'm half asleep. I'm trying to finish this. I'm sorry about that. Maybe I said it wrong. That's my fault.
Anyways, that was it.
Okay. All right, Jason, go ahead.
How do you find your greatest common factor? Like, how is it 30x?
Well, when it comes to constants, the way to do it is to kind of find the prime factorization. So, and you don't have to do it like when it comes to these word problems, you could just multiply all three of these together and you get the number, and it would work. Like 15 times 2 gives you 30. That would work. It's fine. But another way to find the prime factorization, like the prime factorization of 2 is just 2. The prime factorization of 15 is 5 times 3.
Mm-hmm.
And then from there, you find the LCD, and you treat each of these as their own individual factor. Have a 2, so that goes in the factor, the LCD. Have a 5 only once, that goes in the factor. Have a 3, that goes in the factor. So that's 30. And then you also have x that goes in there.
Yeah, but we also have 1x at the beginning. So why won't you do times 1x, which gets you a 30x squared? Why would you not do that?
I mean, you could do it that way, but the thing is the x is redundant, and that's because the extra x is redundant, and that's because you don't want to double count something. I have a factor of x here and a factor of x here, right?
Mm-hmm.
So they both have a power of 1, so you only put it in once. You don't want to double count a factor, so add a factor of x to the first power happening once. I only put it into the LCD once.
Oh, okay.
Does that make sense?
Yeah.
All right. Any other questions? Are we okay? All right, let's keep going. So now when I solve this out, I get 45 equals 2x, or x equals 22.5. So that right there is going to be Albert's speed because Albert goes twice as fast. So that means Albert finishes it in 22.5 hours. And then Jim is working, twice as slow. He's slower than Jim. So Jim is going to be 2x, which will be 45, which we have right before that as well. And there's your answer for that one. Ifek, go ahead.
I'm kind of confused about like the 30 plus 15 part because you just stopped in the middle and I kind of forgot. Could you please go over that?
Oh yeah, so what I did there is I took all this and multiplied it all by the LCD of 30x on both sides. So 30x times 1 over x is 30. 30x times 1 over 2x is 15 because 30x divided by 2x is 15. And then 30x times 1 over 15 or 30x divided by 15 is 2x.
Okay, thank you. That makes more sense.
Perfect. Tanish, go ahead.
How does the 6,000 like work into the answer? Like, does 6,000 have anything to do with this?
Yes and no. Because if you do the word problems today in class, you can see that what you set your top part of 1 to be really is really up to you. Like the 1 in this case, I said 1 unit of work kind of is painting a 6,000 square foot of hallway. If I wanted to, I could say, well, 1 unit of work is painting 1 square foot or 20 square feet or something like that. Something stupid like that would make no point. So you could have changed that 6,000 kind of relates with that 1. It depends on what your unit of work is. Is that in this case, since everyone's painting a 6,000 square foot of hallway, we're just saying, well, 1 unit of work, which that term makes no sense to me, but we're gonna roll with it. That 1 unit of work is 6,000 square foot of painting 6,000 square feet of a hallway because they're all doing the same thing. So that's what we said. That kind of unit of work to be. Does that
So
make sense?
you would have still gotten the same answer if you would have replaced all three of the ones with 6,000.
You would have, and that's because that time of x will tell you how fast they would be able to do. They'll be able to paint 1 square foot of it'll tell you how fast they can paint 1 square foot of that hallway. Is that your final answer? You'd end up multiplying by 6,000 to put it back into 6,000 square feet of hallway.
Okay, got it. Thank you.
It really depends what you're setting everything to be. Is that in these problems, we're just kind of keeping it simple and saying, well, 1 unit of work or whatever it is, whatever you want to say it, is painting that 6,000 square feet of hallway. Any other questions, guys? Are we okay? Ready to move on? All right, the next problem is going to be in your extended practice. There was also a warm-up. So if you did the warm-up, you would recognize this problem. And we are going over it. All right, so the rational equation, 1 over 3 minus 4 over x equals x minus 1, gives the same solution as which quadratic equation? So basically what I want to do is I want to reduce that whole thing. I want to fix it and make it not look ugly like that. So what I can do is I can take that 1 over 3 minus 4 over x equals x minus 1. What I want to do is I want to get rid of this x right. I want to get rid of this x right here in the bottom. So what I can do is I can multiply this fraction, this whole thing right here, with x over x. Right, x over x is still 1, so I'm not changing the value, but I can still do that because I can just distribute it in now because I'm not changing the value. So x times 1 on the top is x. On the bottom, I can distribute this x into both these two fractions. So I get 3x minus 4x over x, and that equals x minus 1. These x's cancel out. And what I'm left with is x over 3x minus 4 equals x minus 1. And then from here, what I want to do is I want to get rid of this denominator. So I can multiply both sides by 3x minus 4. Because when I do, I get rid of my denominator. And what I'm left with is x equals x minus 1 times 3x minus 4 gives me 3x squared minus 4x minus, ugly 3, but minus 3x plus 4. We can start combining like terms. So from the right side, I have 3x squared. I have negative 4x minus 3x. And when I subtract an x over here, I get negative 8x. And I get a 0 on the left side plus 4. So I have 3x squared minus 8x plus 4, which gives me a. So the big part here is this very first step of knowing how to get rid of that kind of fraction inside the other fraction. Any questions about that? Make sense? If not, that's really all I have for you guys. I think that's a pretty good review for the test. My big thing I'm going to say is be good with factoring. If you're not good at factoring this test, it's going to be kind of hard for you. And, well, I don't know if hard, but it's going to be long. If you're not fast at factoring, it's going to be a long test. Anon, go ahead.
So at the first part of the equation, why did you multiply x to the left side of the equation and not the right side?
Because x over x is equal to 1. I don't need to do on both sides because x divided by x is 1. I didn't change the value.
Oh, okay.
All right, guys, I'm here till 8. If you have any questions or any other problems you want me to do, let me know and we can go over it. 54. Faith, go ahead.
Can we do number 54, 53?
All right, so 53 and 54. All right. Let me pull this up. So, Fatima asked first, so the 54 first, and then we'll go to 54. 54. 53, and then see Abraham, see tomorrow, man. And 56. All right, then after that, I'll turn off the video. Okay, we'll do these two problems. Number 54. We're told one car travels 4 miles per hour faster than another, and the time it takes a slower car to travel 96 miles, the faster car travels 104 miles. So what I'm told is that the time for these two situations are equal to each other. So the time for the faster car equals the time of the slower car for this very specific situation right here. So the time of the faster car, or just time in general, is distance over speed. So the time of the faster car, I'm told he or she, whatever it is going 96 miles per hour, or a total of 96 miles at a speed that I don't know. So let's just call it X. And that's going to equal the time of the slower car who's going or driving a total of 104 miles over his speed, which I don't know, but I know that one car is going 4 miles per hour faster than the other. So if the faster car is going X, the slower one is going that speed, but minus 4 miles per hour. So that's what I get, and that's what I'm going to solve. My LCD is X times X minus 4. So you multiply 96 over X with this LCD. The X's cancel out, and I'm left with 96 times X minus 4. And on the right side, when I multiply 104 over X minus 4 with the LCD, X minus 4's cancel out, and I'm left with 104X. So I have 96X minus whatever 96 times 4 is. Figure that out. 384. So minus 384 equals 104X. So from here, I can, what is right? X minus 4. 1 per 4, 1 per faster than another. 96. I flipped it. Sorry. So the faster car it's opposite way, 96. The faster car is going 104 miles. Sorry about that. The faster car is going 104 miles at a speed of X. The slower one's going 96 at X minus 4. So we're going to go ahead and redo that, but it's going to be the same process. Just don't mess that up like I did. So 104 over X times X minus 4. Same thing. The X's cancel out, and you have X minus 4. In this second case, the X minus 4's cancel out. You have 96X. Distribute that out. 104X minus 416 equals 96X. I'm going to move the 416 to the right, 96X to the left, and I get 8X equals positive 416. And 416 divided by 8 is 52. So X equals 52. So the speed of the faster car, so the fast car is going 52 miles per hour, and the slow one is going 48. Sorry, I read that wrong when I was setting it up. That's what you get. Any questions about that? Perfect. Could you also have done 104 over X plus 4 equals 96 over X? Yeah, you can do it that way too, because you're saying the exact same thing. So Malachi, I'm not sure if I'm saying that right, sorry. He's saying, could we have instead done 104. 104 over x plus 4 equals 96 over x. And you could, because what this is saying is that the slow car, this is the time of the slow one, he goes 96 miles at a speed of x, while the fast one went 104 miles at a speed of the slow car speed plus 4 more miles per hour. So it's a little different than what I did, but it's saying the exact same thing. So both these ways would give you the same exact answer. They both would work perfectly okay. All right. Any other questions? Ready to keep going? All right. Now let's go on to number 53. Number 53 is saying one car travels. Did I just do this one? No, different. All right. One car travels 9 miles per hour faster than another one. The faster car can complete a 108-mile trip in 2 hours less than the slower car. Set up and solve a rational equation to find the speed of each car. So there's two cars, a slow one and a fast one. And I know that the difference between these two cars is equal to 2. So I know when I subtract the speed of both these cars, I get a 2. They have a difference of 2. But when it comes to differences, you have to be very careful with how you set up these subtraction parts. So if I said the time of the fast car minus the time of the slow car equals 2, I would have to put absolute values because the time of the faster car is going to be smaller than the time of the small car. And this part right here, it would work, but I'm sure a lot of y'all see absolute value signs that you don't want to do. So when you're setting up any type of difference problem like this with word problems, try to always kind of think, well, which number is going to be bigger? And in this case, the time of the slower car is going to be bigger than the time of the faster car. So I'm going to put the time of the slower car minus the time of the faster car, right? The slower you are, the longer it takes you to finish something. So I'm going to put it this way so I don't have to deal with any absolute values. So I have T sub S minus T sub F equals 2. And the time of the slower car, I'm told, is going to be, well, I don't know what it is, but I know he's driving 108 miles at some speed that I don't know. We'll just call it X. And the faster car, he's going 9 miles per hour faster than the other. So they're both going the same distance. They're both driving 108 miles, but the faster car is doing it at an average speed of 9 miles more. And this equals 2. And then from here, I can solve this out. So LCD is x plus 9. Multiply that out. So 108 over x times this x times x plus 9. The x's cancel out, and I'm left with 108 times x plus 9. Well, the 108 over x plus 9 times this LCD, the x plus 9's cancel out, and I'm left with a negative 108x. And that equals 2 times x plus 9. You have to multiply the 2 with the LCD as well. So distribute this out. I'm going to solve it out. So 108 times x is 108x. 108 times 9 is 972. Minus 108x. And here I basically have a 2x right here. I can distribute this in to get 2x squared plus 18x. The 108x and a negative 108x cancel out, and I have 972 equals 2x squared plus 18x. I can divide everything by 2. So 972 divided by 2 is 486. So I have 486 equals x squared plus 9x. Or I can rewrite this as x squared plus 9x minus 486. And now I need to figure out what does that factor out into? Or you could use the factor or quadratic formula, whatever you want for this one. And it looks like what it ends up being is 18 and 27. Not 18, 27, but it ends up being, let's figure it out. So 18, yeah, so I can get x minus 18 and x plus 27. That's what it factors out into. I just kind of looked at the key to figure that out pretty quickly. I was going to try to do that in my head. You won't get any numbers that big on the test anyway. And I get that x equals 18 or negative 27. This negative 27 doesn't really make any sense. So we can cross that out and figure out that x equals 8. So that's the speed. If I go back to my original problem, how I set it up, I said the speed of the slower car is x. So this tells me that the speed of the slower car is 18, and the speed of the faster one actually ends up being 27 as well. That won't always be the case where the factors give you this number here. It just happened in this case. I guess you can kind of say it's a coincidence, but in this case, just the coincidence happened. So your answer is the slow car is going 18 miles per hour, the fast one's going 27. Make sense? Are we okay with that problem? Ready to keep going? Or is anyone still copying or have any questions about this? $56. We'll rather do number 56 right now. All right, so this one's really, really weird, but all we need to do is really set it up. So for this one right here, I'm told that a baseball team's winning percentage is equal to the number of wins divided by the number of games played. So like the amount of games you win divided by the amount of games you played tells you how many your winning percentage, right? And a team called the Rankers had 30 wins in their first 72 games. They then got 25 wins in the next 36 games. And then they go on a huge losing streak. They lose a series of consecutive games, entering a losing streak. And we're going to write the rational function modeling the team's winning percentage during each game of their losing streak. Then we're going to use the model to determine how long the streak will need to continue until their winning percentage returns to what it was after the first 72 games. So I'm told that this team originally had a 30 over 72 win percentage. And I want to know, well, after this pretty good win streak right here, the 25 and 36 games, and after that huge losing streak that I don't know how many games they lost in a row, I want to know, well, when does that, how many games do I need to lose after that 25 wins and 36 games? Do I go back to the same win percentage of 30 over 72? Or in other words, after I won 25 games and 36 games, my new win percentage is 55 over 108. Or in other words, I added 25 over here, right? It's from the 5 wins there. Then I added 36 here because they played a total of 36 games after that original 72. But then I go on a pretty big losing streak. So I added 0 wins, but I added an N amount of games. I don't know how many games they played or how many games they lost in a row. So this is what I'm going to say. Well, 55 plus 0 wins all over 108 plus N. How did I know put an equal sign? That's because I'm told right here, I want to write a rational function modeling the team's winning percentage during each game of the losing streak. And right here, use the model to determine how long the streak will need to continue until their winning percentage returns to what it was after the first 72 games. I want to figure out, well, what's it called? The amount of games I need to lose to make this 55 over 108 back to 30 over 72. Because after that 25 wins in 36 games, I'm at a win percentage of 55 over 108, right? And then I go on a big losing streak. I don't know how many games I'm losing, but I know that, what I'm trying to figure out is how many games do I need to lose to make this 55 over 108 equal to 30 over 72 again. So I add 0 wins because I'm not winning anything. I'm on a losing streak, but I'm adding an N amount of games. I don't know how many they are. That's what we're asked to figure out. So that's why I can say, well, the equation that models that is 30 over 72 because that's the win percentage that I'm looking for. And that's going to equal my 55 wins for my first 30 wins plus the next 25 that I got right here over 108, which is the total amount of games after the first 72 and the next 36, plus every single game in that losing streak of N. I don't know what it is, but I'm losing that many games. And that's what you get. And you can solve it out if you want to, but I don't think you need to. Does that make sense? I think, who was asking for that one? Trisha and Faith. Are y'all okay with that problem? So I know it's gonna be a little confusing, but that's kind of the logic that's going behind it. Sorry? I heard someone talk. All right. Alden, go ahead.
You know, I know I know why 108 plus n works, but I'm just wondering, because it's a ratio, couldn't you also just put like x for the denominator? Because you're just trying to make a ratio here, trying to make it the exact.
But the thing is that x can be a lot of things, and I want to know for sure that I have to have at least 108. It's 108 plus the other plus the n, and I want to figure out what n actually is. Not what the whole denominator is, but what n is. So you could put 55 over x and then take that x value and minus 108 from it. You could do it that way, but I think it's just a lot of extra work to just say 108 plus n. It's like the thing with math is like you could do stuff a lot of different ways. A lot of those ways are kind of like you could, but why would you want to do that? You know, kind of like this right here. You could say 55 over x, and then once you get your x value, you can say x minus 108 to figure out how many losses you have. It's kind of like, well, why not just put 108 plus n at the bottom and solve for n? You know what I mean?
I guess. To me, it just seems simpler.
You could do that way. You just have to remember to minus the 108 at the end.
Yeah.
$17, $18. Now do those? Did not. Okay. I'm gonna stop recording now. So the video isn't too long.